new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear. This is Eric Riney from Webster University coming at you again with another marketing analytics procedure. In this tutorial, we're going to be discussing data cleaning. Let's get started. Many people wonder why is data cleaning necessary, and really what they are challenging is the notion of data cleaning. In other words, the ethicalness of manipulating data. But remember, our goal in research and data analysis is to get to the truth. So ask yourself, if a respondent has not provided enough data for it to be useful, or he has mindlessly answered questions, should we keep that data and use it? The goal of data cleaning is to cleanse it of bad information. That said, if someone is conducting data cleaning in a way that manipulates data so that it leads to desired outcomes, regardless of whether that is the truth or not, that is unethical and should never be accepted. Once you've accepted that data cleaning is not only okay, but it's necessary, the second challenge with data cleaning is that you might be faced with the desire to have a certain amount of data. This leads to the second challenge of data amount versus data quality. Hopefully, if everything goes well, you've collected enough quality data that you won't be faced with this challenge. But there may be circumstances in which you will face a small amount of data and you have to decide how you will delete precious data points. It's much easier to be liberal in deleting data when you have a large data amount. It's much more difficult when that data size decreases. Data that you might otherwise delete, you find yourself keeping because the sample size is just too small. This leads to the challenge of establishing policies about actual data cleaning. It's good to have a standard policy that the organization follows. However, more than likely there will be some variation between projects because the idiosyncratic nature of each data you are working with demands it. The first policy involves data deletion. That is, determining when data should be removed. If a case, that is, a respondent, has skipped 70% of the questions, it's probably pretty easy to decide to delete this person's information. But you have to determine how small of a percent of missing information is allowable. 10%? 20%? Maybe it's not just as simple as the amount of data, but what's missing in the data. If 30% of the questions were skipped, but the most important information was provided, should we keep the data? Maybe, maybe not. In another situation, you might be faced with a respondent who has knowingly falsified information. This would be easy to delete. But there are other circumstances where you have to attempt to identify whether someone has falsified answers. You will have to establish the test to determine whether or not answers are truthful. There is a third situation in which an actual item, that is a question, might have to be deleted. It, for some reason, a large number of respondents misunderstood or skipped a question. You might have to remove it because it's flawed or the information that results is missing. If you feel uncomfortable about deleting data, just think of data as a bush. In order to have a more vibrant looking bush, you have to trim the dead parts so that the living parts can thrive. This is the same thing you have to do with your data. Now, whether or not you delete data, you will probably still have to contend with missing data. Oftentimes, this is due to respondents inadvertently or intentionally skipping questions. It could also be because data transfer errors such as answers not being transcribed correctly has occurred. Now, this situation doesn't happen very often anymore because a lot of times data is automatically collected in a computer or some electrical format, so we don't have to worry about that. However, because most statistical software cannot function with missing data, it's important that we do something with the missing data. Therefore, you will either have to impute, that is, insert or omit data from the analysis. Omitting data is different from deleting it. Omitting means we don't use certain data in some analyses. Deleting data means it is completely removed from all analysis. Similar to deleting data, some people will have an issue with the idea of inserting data where there currently is none. However, with some scientific approaches, we might be able to ascertain the missing data and what it should be. For instance, you know the letter I is missing in the word. By inserting the missing I, we have actually completed the data. Of course, this is not as easy to do when it comes to understanding perceptions and feelings and how those translate into coded data. But I'm going to show you some useful techniques that will help you to be more comfortable and confident in data imputation. Realize that there is no exact science to follow with determining how to conduct data cleaning. The goal is to have better data. There really is no guarantee that the data is going to be closer to the truth. However, using a systematic approach that can be justified will allow data analysts to be more confident in results. So let's take a look at the steps that we actually go through when we're doing data cleaning. The first thing that you'll probably run across as you get your raw data from whatever data collection source you use, whether that's SurveyMonkey or Qualtrics or some other tool, more than likely it's going to have some data that's been added to it, some markers or headers. And you really want to get rid of that because a lot of that is unnecessary. It may have an IP address. It might have things like the location. If that information isn't important to you, it's better to get rid of it. Same case with headers. Oftentimes you'll see a question number as one header, and then you'll have a secondary subheader that might actually have the question itself in there. You may want to combine those two into something that really refers to what that question or item is. The second thing you want to do is add an ID number. Now, oftentimes your data collection package will give you an ID number, but it's really a long string, and oftentimes it's more cumbersome than anything. It's better just to have an ID number that starts with 1 and takes you all the way through however many cases you have. For one thing, this will let you know how many cases you started off with. Another thing is that it's easy to identify cases, and if you have to delete a case and you want to go back and identify what cases were deleted, it's a little bit easier to use just a simple ID number. The next thing you want to do is to create multiple worksheets to work with as you're doing your data cleaning. The reason for this is because when we're doing this in a systematic way, you want to make sure that you are keeping track of everything you're doing. I don't know how many times I have not listened to myself and gone ahead and just used one worksheet to do everything in, made a mistake when I was further down the process and had to start all over because I didn't know what I had done. I didn't know where the mistake may have happened, and there was no way for me to kind of piecemeal my way back to a point where I could say with confidence, this is good data and I can move forward. So you want to be careful. You want to have, first of all, working data sheets. All right. You want to have your raw data. You want to keep that left alone. So you want to copy your raw data over into a working sheet. And I would suggest that you even do this before you start deleting unnecessary markers or headers. You should add your ID at that point, and then you can move forward with copying interimly your worksheet as you're working down the process. It's good to have different steps in the process as different worksheets. That way, let's say you've done some deletion of cases and it turns out you made a mistake in the way you were deleting cases, or somebody determined that the policy you were using needs to change. It would be very easy for you to go back to that point and start from there. And the same thing with imputation and other things that you might do with data cleansing. Second sheet that is really important to have is a code sheet. The code sheet is your answer key. It lets you know what your data means. It is the key to what the numbers represent in your data. Data usually is analyzed using numbers. So even though those numbers may represent something such as level of satisfaction, completely satisfied, not at all satisfied. So 1 may represent not at all satisfied, or 5 may represent completely satisfied. However, you may not know what those numbers represent when you're looking at them in your data. Be really careful. Don't get overconfident that you're going to remember what those numbers mean, because somewhere down the line, you're going to put this data down and you may pick it up and you won't understand anything. It's better to have that code sheet. The code sheet will also tell you if there's reverse coded items, and we'll talk a little bit about that in a second. It'll also tell you in terms of skip patterns. So it's good to have all of that information in your code sheet. It may also identify what your actual scales are. Again, great information to have in your code sheet. The next sheet is a deleted case sheet. So as you're going through and you delete various respondents or cases, you want to move them over somewhere else. You don't want to just delete them away. For one thing, it's good for you to keep track of what cases are being deleted. You may do some analysis on those deleted cases to see if there's anything systematic in what's being deleted, in terms of maybe a certain age group is being deleted more, or perhaps a certain gender is being deleted more, a certain other demographic, maybe a certain target group is being deleted more often. And if that's the case, then maybe you need to figure out why that's happening, and you might have to actually collect more data before you move forward with your actual analysis. Something else that's good in your deleted case sheet is that you just keep track of the total number, right? It's very easy for you to really just be able to count how many cases you've deleted. All right. The last sheet is a tracking sheet. This sheet should provide an explanation of everything that you're doing as you're working through your data cleaning. The reason for this is because if there's someone that wants to come behind you and look at the work you've done, it's very easy for them to see what you did. Why did you delete certain cases? What was your methodology used to delete those cases? How did you determine how you wanted to impute data? All of that is really great information for you to have, because again, if you put this down and you come back to it a week or 2 weeks later, sometimes you don't know where you left off, you don't know what you've done, and you may not even remember exactly how you did it. Having that tracking sheet will provide that invaluable resource. The next thing you want to do is reorient reverse coded items. All right, so what are reverse coded items? Reverse score or reverse coding is really where we have these items or questions in our questionnaire, and the answers are scored numerically in the opposite direction of the other scores that relate to that particular scale. So let me give you an example of this. Let's say we have a 4-item instructor satisfaction Likert scale. And if you remember, a Likert scale is simply a scale where we ask people their agreement to items or to statements. All right. In this case, we have 4 of those statements that we're using, and we're going to create a scale of how satisfied respondents are with their instructors by the answers they give us on these 4 items. So these 4 items are: the instructor was knowledgeable, and if the respondent scores a 1, a marks a 1, that means they totally disagree with that. All the way up to a 5 means they totally agree with it. All right. Instructor provided effective feedback. Again, it could be 1 to 5. So each one of these items could be scored from 1 to 5. You could see that the 3rd item, instructor was difficult to understand. This actually is in the opposite direction of the orientation of the rest of this scale. So if you look at items 1, 2, and 4, the higher the number, the more satisfied the respondent is with the instructor. Look at 1, instructor was knowledgeable. If you totally agree with that, that indicates that you're more satisfied with the instructor. Item 2, instructor provided effective feedback. Again, if you score a 5 on this, that means you're more than likely pretty satisfied with the instructor. But if you score a 5 on 3, instructor was difficult to understand, this is an indication that there's something you're not satisfied with the instructor. Now, looking at item 4, instructor was fair. Again, if you score a 5, this is an indication that the person is satisfied with the instructor. So, a satisfied respondent's answers might look like this: a 5, a 4, a 2, and a 4. Why? Because, if you look at the 3rd item, instructor was difficult to understand, and the fact that they scored it a 2 means they didn't agree that the instructor was difficult to understand. That means the instructor probably was pretty easy to understand, and they were satisfied with the instructor. Compare that to a dissatisfied respondent. If you look at this one, in this example, item 3 is scored high. All the other items are scored low. Again, this is an indication that the respondent he's not satisfied with the instructor. So what we want to do is we want to reorientate that reverse scored or reverse coded item so that it reflects the same direction or the same orientation as the rest of the scale. So the satisfied respondent should look something like a 5, a 4, a 4, and a 4. The dissatisfied should look more like a 2, a 1, a 2, and a 2, or maybe a 2, a 1, a 1, and a 1. All right, so that's what we want to do when we reverse code. This is important because as we are summing our scale and as we're looking at cleaning our data, this becomes extremely important to us. Another step we want to take is actually deleting data, either list-wise or case-wise. We want to delete the data. All right. Again, we'll get into steps of how we actually delete data. A list-wise deletion is where we actually delete an item. A case-wise deletion is where we delete a respondent or a case. Impute data is the same thing. We can have it list-wise or case-wise. Now, the difference between deletion, which is an and, you can do list-wise and case-wise. With imputing data, You often only want to do one or the other. You want to be consistent in how you impute the data. Okay, so now we're inside of a data set, and this data is related to a survey that was done regarding perceptions of a learning tool using gamification. And there are a variety of scales that were used. Basically, it was to understand levels of satisfaction and various things that play into a person's level of satisfaction. One of the things that you see here on the front end of this are these 10 variables, and this is information that was added by Qualtrics on the front end of this questionnaire. Just marker information. This V1 is an arbitrary ID that was added. You have an IP address here. You do have a start date and an end date, as well as whether or not the respondent finished. You have to be careful with this finish indicator. It's just 0 or 1. So 0 means they didn't finish, 1 means they finished. But that simply means they made it to the end of the survey. It doesn't mean that they actually answered all the questions. If there's a way for them to skip to the end, as long as they reach the end, they'll have a 1 here. So that's information that may not be very useful, at least on the face of it. As I mentioned, a lot of this information is unnecessary, and it's information that we'll end up deleting. We also have these double headers, and most statistical packages, as well as Excel, don't play very well with 2 headers. They tend to look at the second row as data and only the first row as header information. So it's better for you to just have 1 row as your header information. So what we want to do is combine these two. Let me just explain to you right here what's going on. This is something that Qualtrics does. I believe SurveyMonkey does this as well. So if you have a scale that has multiple items in it, multiple questions in it, and you put it in a matrix form, what you'll have is one question with multiple items, and that's what this represents here, Q1_1, Q1_2, all the way through Q1_7. It simply means this was one matrix question, and there were 7 items that made up this question. And you see the subheader here indicates that this was a playful scale, and I just labeled these playful 1 through playful 7. You also see here for playful 5, it's actually playful 5R. And this 5R means that this is a reverse coded item. And it's really important that you make sure you label those reverse coded items, and make sure you keep track of those. So this is where we will begin with our data. We're going to have to clean a little bit of this up as we move forward. And that's what we're going to do. The other thing you see down here is that we have multiple sheets that we're going to work with, okay? With your raw data, you want to make sure you hold on to that, and you want to actually create a separate working data. So just copy your raw data over to another sheet, and then start there when you begin to make any changes at all to your data. All right. I also have a code sheet here, a deleted sheet, and a tracking sheet, and I'll just spend a little bit of time talking about each one of those. Okay, so now let's take a look at our code sheet really quickly. And this code sheet is just a cheat sheet. It lets us know what's going on in terms of what each number represents in our data. You can see here that all of our major constructs that we're measuring are using a 5-point Likert scale. So that's what we have here listed. I also indicate for playful, there is a reverse coded item. It's item number 5. Useful also has a reverse coded item. That's item number 2. And again, you want to make sure you keep track of this. It's good to keep track in your data. It's also good to keep track on your code sheet. I have some demographic information down here as well. Female is coded as 2, male is coded as 1, and education has various codes as well associated with it. So that's just a little bit on your code sheet. There's some additional information we could put on the code sheet if you so desire, but this is at least the basics of a code sheet. And really, this is, there have been so many times where if it weren't for my code sheet, I would have been lost, because I put my research down maybe 2 weeks, maybe even 3 weeks, came back to it, sometimes even a year later in terms of research I'm doing, academic research. And you just don't know. Sometimes you don't even know the orientation of the scale. So here we see that as it goes up, as the numbers go up, that indicates that there is higher agreement, which means a more positive orientation. Sometimes your scale could go the opposite way, where this is 1 through 5, strongly agree is 1, and 5 is strongly disagree. And you may forget that that's the orientation of the scale. So it's just really great information for you to have to refer to. Okay. We also have our delete sheet, and this is where we're actually going to, when we remove our cases, we'll move them over to the delete sheet. We don't actually want, and it says delete sheet, it should say delete sheet. We don't actually want to delete stuff permanently. It's good to hold on to it. So I've created this sheet over here just for that purpose. I'm going to change this to delete. I also have a tracking sheet, and this tracking sheet is going to be used to just mark down and indicate what I'm doing as I'm going through and cleaning my data. All right, so there you have it. Those are my various sheets that I'm working with. Okay, so now we're going to move forward with getting rid of this information that is unnecessary, getting a 1-row header, and moving forward with our data cleaning. And I've actually already done this initial step of deleting those variables that were unwanted. I did keep the start and end date. I added in an ID number, just 1 through. You can see here there's 400. So I added in just a number for each respondent. So I have a good indication of how many I've started with. Plus I can keep track of the various cases and what I'm doing with those various cases. Here I'm putting a timestamp in. This timestamp is just how long it took for the respondent to actually complete the survey. And you can see it's just the end date minus the start date. Here I've done this, I formatted it so that it's just hours, minutes, and seconds. If they did this over multiple days, you could actually add day in there as well, but I didn't want to format that in there. All right, you can see I also, for this first row, I've deleted and collapsed the first and second row into a 1-row header, and I've taken that Q1_1 and that playful and created my own header, just abbreviated P1 through P7. I did keep in that P5R so that I know this is a reverse coded item. And just in case I don't know what the P stands for, the KN stands for, the AU stands for, I can go over to my code sheet and I have those listed here on my code sheet just as a reminder. So again, it's just great information for you to have. All right, so that's basically setting up my working data, and if you remember, we don't want to use our raw data. We actually want to copy our raw data over into a working data sheet and use that. So that's what I've done here. And now we can begin the process of actually cleaning the data. Now we can begin our data cleaning, and the best starting place for the data cleaning is to delete unwanted cases and items. Now, I mentioned in my steps to start with reverse coded items and reorientating those, but it is really better to start with deleted items. And the reason for that is that your reverse coded items could be a great indication of whether or not a respondent was paying attention. So you can see in our reverse coded items, for instance, if we take a look at, let's see, an individual, and let's kind of, I'm just trying to get a good, here we go, like this right here, both of these. If you look at user, the usability scale, or I think this is usefulness scale actually, you see that both of these respondents answered 4, then 2, 4, 4, 4, 4, 4. Now, had they answered 4 all the way across, that's probably a good indication that they weren't necessarily doing this with all seriousness and they were just entering data. And so reverse coded items are good just for that purpose alone. All right, we can see over here with the playful scale as well, where we have 2, 2, 2, 2, 4, 2 on both of these. And again, that's just a great indication that these individuals are taking the questionnaire seriously. All right. So before you reorientate the scale so that your reverse coded scores are going in the same direction, it is good for you to at least take a look and see if you need to delete some cases due to the fact that they just weren't taking things seriously. All right, so where should we begin in terms of deleting cases? The best place to start is to delete cases that are missing a lot of information. All right, so I'm going to come to the end of my data and I am going to identify those cases that are missing a lot of information. And one of the things I want to mention is that I like doing my initial data cleaning in Excel because I think that Excel just works a lot faster and better in a lot of ways. It's just easier to get things done in Excel. There are some things that work a little bit better in a statistical package like imputation, but for the most part, Excel can do a lot of your basic stuff. So again, I'm doing count blank here, and what I want to count are really those factors that are really important to me in this actual study. So I'm skipping the demographic information because it's useful information, but it's not that important to me. It's not as important as this other information, and that's what I want to focus on. So we see here that this first case, this first individual actually answered all of the questions. That's awesome. That's a good start. All right, I'm going to copy this down and see for the rest of them, do a sum for each one of these individuals and see. Now what we want to do is actually sort our data, all of our data, based on this blank from largest to smallest, and we can see, wow, we have at least 4 cases, I mean 2 at least, but maybe 4 cases where there's a significant amount of information missing. And just so you know, I have only 43 items that they have to answer. So these first two, 41, they didn't answer anything. It's no telling what happened here. This could happen in your data no matter what you do. Sometimes computers can hack into your questionnaire, and they can add information and do crazy things. You just never know. So I'm going to get rid of all 4 of these. And again, it's up to you to determine what you think is a cutoff point for deleting because of blanks. But I have 400 respondents, so I'm good with even this 13. There's a lot of holes here, and I just feel, hey, I can get rid of these and still have a lot of data to work with. So again, I don't want to just delete. I want to cut this information and put it over into my deleted folder and hold on to this information because I may want to take a look at it later on and possibly do some analysis on it. Oh, let's try that again. All right, and paste over here. And then I want to track, and here I want to indicate why I deleted. So what did I do? I deleted 4 cases due to large amount of blanks. Okay. And so now that's the starting point. I'm going to delete those, and now we can take a look at this next case, and it's missing 7, and we see here that it's this person, for whatever reason, skipped the satisfaction scale, answered all the rest of the questions, but skipped the satisfaction, which is really curious. The satisfaction scale is probably the most important scale for a respondent to answer. This whole survey is investigating the satisfaction level of the gamification tool, and then looking at all of these other factors and how they influence or impact satisfaction levels. So without the satisfaction score, there's not much I could do with this respondent, even though this respondent answered all the rest of the questions. So I'm going to get rid of this person simply because they didn't answer the most critical question. Again, I'm cutting and pasting. I'm going to indicate why. And in this one, since it's only one respondent, I'm going to indicate the actual case. So deleted ID 396 due to no answer on satisfaction scale. And then I'm going to get rid of this blank row. All right. Now we have 3 that are missing 6 items, and eyeballing this first person, I mean, it's kind of arbitrary where they skipped, and it looks like I might be able to fill in these gaps. So I'm going to hold on to this for the time being. I'm also looking at these next 2, and for whatever reason they skipped this user scale, useful scale, except for the reverse coded. Again, really suspect. But for now, I'm going to keep them because they do have the satisfaction information here. Plus they have all the other information. So what I might end up doing with these two cases is removing them from any analysis involving the useful scale, and then just use them if I want to look at any of these other scales in satisfaction. So they still have some good information there. And looking at the rest of these, I mean, again, just arbitrary, missing, they've skipped for whatever reason. So I'm going to hold on to these for now. Okay, so I've gotten rid of cases due to blanks. Then the thing you would also do, and I'm not going to do it here, but the same way I did each case totaled for blank, just to see, count how many blanks, you could do that for the items or the actual what we call the list in the data. So each one of these questions, you could go to the bottom, do a total blank, count the number of blanks, and see if there's an item that's missing a large amount of data. And if it's missing a significant amount of data, and I'm just eyeballing this and I don't see anything, but if that's the case, then you might want to actually delete one of your items as well. But that's not the case. So I'm not going to worry about doing that. Okay, so the next thing we're going to do is to try to identify respondents who may not have taken this questionnaire seriously, and we want to get those deleted as well, because if they didn't take it seriously, then their answers aren't reflective of the truth, and so there's no need for us to keep them in our data analysis. One of the first ways to do this, and you know, this goes back to the reverse coded items. So, you know, with reverse coded items, if we had already reorientated these, we wouldn't be able to catch things such as if a respondent were to mark all twos, two, 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 all the way across. Well, even for that reverse coded item, that would be a good indication that they weren't paying attention to the questionnaire and they were just trying to finish. This does happen from time to time if you have a good incentive and the respondent just wants to finish. Could be a student that wants to get a grade. It could be that somebody wants to be put into a lottery to win something nice. And so they just complete the survey. But you can see here, for instance, this respondent marks all twos, but then there's a 4 for the fifth one, which is reverse coded. So this is a good indication that this individual seems to be paying attention. All right, so a good way to look and see if a respondent is just marking the same answer across all of the responses is to measure the deviation. So if we do a standard deviation and see how much variance there is in their answers, we can see if, in fact, they are marking more than one specific answer. So I'm going to come over here and create another column, and I'm just going to call this standard dev for standard deviation equals standard D, and we want STDEV. This will give us a measure of standard deviation. And if you remember, standard deviation is the measure of deviation of each point in regards to the mean score across the points. All right, so again, I'm only doing these for the questions, so I'm not going to look at the demographic information, and I'm going to hit enter, and I'm going to copy this all the way down. And in this case, we want standard deviations to be, I'll say we don't want them to be small. We don't want them to be 0. A 0 standard deviation indicates that they don't have any kind of differences in the responses to the questions we're asking them. So in this case, we're going to sort the entire data set by standard deviation, and we want to sort smallest to largest. And we see there are 3 here right off the top that don't have any kind of deviation in their scores. This person's marking all 4s, the next person marking all 5s, the next person is marking all 3s. There's no reason for me to analyze this data any further. I'm just going to delete it. Just get rid of it. There's no need to hold on to this data. I mean, reverse coded items, if there are 5 on the rest of these, you would expect them to be low on the reverse coded item. The same thing over here when we're looking at the reverse coded item for usefulness. Okay, so delete these, put them over here, and then tracking. Delete 3 cases due to 0 standard deviation. I already typed that in. Okay, so that gets rid of that, and I'm going to hit delete here. All right, so the next thing to look at is some of these lower standard deviations that are not quite 0. I mean, you can kind of eyeball these, and you know, that looks like they're doing a little something here, but not much. And sometimes, you know, smart respondents know that, hey, I can't put all the same number. Maybe if I just do a little bit of change, maybe they won't know. All right. Again, it's up to you to come up with a standard of what you think should apply here. A way I like to analyze this is to not only look at the standard deviation, but do a combination of standard deviation and the time spent. For this particular questionnaire, I would expect them to take at least 4.5 minutes, maybe 5 minutes to do this questionnaire. So anything that's less than, I'll say, 4 minutes, and with a low standard deviation, that combination, I'm going to get rid of it because that's a good indication that they're not taking this seriously. Maybe they did, maybe they didn't. I just don't want to take that chance. So I'm going to get rid of 1, 2, 3, 4, 5, 6, 7, 8 of these. Put this over here. And under tracking, deleted 8 cases due to combination of low standard dev and time. All right. Then we can delete this. Okay, another useful check, I didn't add it in this questionnaire, but in some cases, instead of using reverse coded item, you might add in a question that says mark 99 or mark a certain response of some kind, and that lets you know if the respondent is actually paying attention. And that's something else that you could use, because if they didn't mark 99 or follow directions, then that's an indication that they're probably not paying attention and you might want to delete them. So that's another useful tool that you can include in your questionnaires. Okay, so my other standard deviations, 0.5 and above, and again, it's up to you to determine what you want to use as a cutoff for your standard deviation. I mean, there are still some individuals here that might be a little suspect, but in terms of this one, 3333, this is not anything out of the ordinary. This is in the middle of the actual scale. So if you mark a 3, you might be a 3 across the board on this particular scale because it's right in the middle. And that individual could be that. So you couldn't use a reverse coded item here to assess this. We do see here for 2444, this is a good indication that this person is honestly looking at this survey, even though, there is not a lot of deviation in their scores. And they did take, 4 minutes. So while it was somewhat quick, it wasn't that quick. So I'm going to go on and keep this person. All right. So the next thing I'm going to look at is the actual time. So the first go round, we did a combination of standard deviation and time. So now I'm going to do a sort on time by itself, and I want to do smallest to largest. And we see there's some other individuals here. They actually have standard deviation, so they have a lot of stuff going on in terms of how they're scoring or marking answers. But, this individual took 43 seconds. The next individual took less than a minute and a half. Not a good sign that they actually took this seriously. I just don't believe that they could complete this survey that quickly. You will find, again, some situations where computers might hack into your system and do something crazy, and that could be the case here, although I doubt it, because usually when you see a computer and it has variation in answers, then this time might only be 7 seconds, or maybe even 2 seconds. So these are probably actual individuals, but again, if they took less than 4 minutes, I'm going to delete them. And one thing you have to keep in mind is how many respondents do you need? How large is your sample size? How many can you delete? How liberal can you be? I can be fairly liberal because, I had 400 to begin with. I still have well over 350 respondents. So, I could even take this up to 430 if I wanted to. I'm not going to do that. I'm just going to stick with under 4 minutes. So I am going to cut these, add them to my deleted sheet. And it looks like we're up to 24 respondents that we've deleted. I don't know how many I just deleted. It starts here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 additional respondents. So here, deleted 8 cases, I'll say, due to low time. And I'll put less than 4 minutes. And then delete this. Okay, so we're going to be moving into data imputation, but before we do data imputation, we're going to have to reorientate these reverse coded items so that they're going in the same direction. So you can see here, we want this scale to have we want each item to have the same orientation. So if we were to score this scale, if we were to sum it or average it, I would want this average to be 4. But right now with this reverse coded item, it's going to throw this average off of 4. And if I were to sum this, this is going to reduce, this 2 is going to reduce the sum of this. And it shouldn't. I mean, I should actually have an extra 2 in my sum here. And it's because this is reverse coded. So that's why we want to reorientate these reverse coded items. A quick way to do this, I'm just going to insert a column right here. I'm going to call this P5. And the way I'm going to do this is that I'm going to simply look at how many points are in my scale. And in this case, we have 5 points in the scale. Don't include this 0. If we included the 0, it would actually be 6 points. But in this case, for each one of these, there's 5 points in the scale. I'm going to add 1 to that. So I'm going to say equals 6, and then I'm going to subtract my actual score. In this case, it's a 3. So 6 minus 3 gives me 3. All right, same thing. It's in the middle of the scale, no difference. But if I copy this down to the next one, look what happens. The 2 becomes a 4. And if I copy this down, a 4 becomes a 2. Let's copy this down further. A 1 becomes a 5. And I'm just going to copy this all the way down. A 5 becomes a 1, and so forth. So now we have reorientated the scale so that it all now, the scale goes in the same direction. I'm sorry, this item goes in the same direction as the rest of the items in the scale. All right. Now, at this point, we have a formula in here, and I don't want a formula, so I'm going to copy this whole column. And do, well, actually, before I do that, I'm going to actually copy this over here and do an insert. And as you can see, it does the same thing over here. Going to change this to U2. All right. Now come back over here, and I'm going to copy this, and I'm going to do a paste special 1, 2, 3, and what this does is it gets rid of my formula and just puts the value in there. So now, instead of having a formula in here, I only have the number. And I'm going to do the same thing over here. Do a copy, a paste special, 1, 2, 3 for the values, and now it replaces the formula with the value. All right, so at this point, what I can do is I'm going to not delete. I'm not going to delete each one of these. I'm just going to cut and put it at the end. Insert here at the end. Just to hold on to it. I never like getting rid of data. I've just gotten burned so many times with getting rid of data. So I tend to move it into, didn't mean to do that. I tend to move it into other worksheets or move it someplace else in the data. All right, so now I have my scales orientated correctly. Those are my 2 reverse coded items. And at this point, what I'm going to do is make a copy of this sheet and create another working sheet. This way I have an interim sheet. All right, so I've done my deletion and my reverse coded. I'm stopping here. I'll create another sheet, and then I'll do my data imputation. And the reason for that is that if I make a mistake going forward, and I'm using the same sheet, it's really hard to backtrack and see where those mistakes occurred. But if I have a stopgap where I can go to another sheet and I know I'm good up into that sheet, then I don't have to go all the way back to the beginning and start over. Again, I've been burned many times, so it's just a great way to do this, is to have these interim sheets. So that's what I'm going to do, is just copy this worksheet. And I'll just call this 3, working data 3, all right? And you could change this to, if you wanted to provide a description of like, this is going to be your imputation data and so forth. You could do it that way. And that way it gives you a better description of what's going on. Okay, so, I am going to go ahead and change this to impute. All right, that way I know what the starting point is for this data or this worksheet. Okay, so the goal of imputation is for us to fill in the gaps of missing data. And as I mentioned, most of your statistical packages don't like blanks. They don't know what to do with blanks. Excel, in most cases, can deal with blanks, but it depends on what statistical process you're using. All right, so I'm going to use the blank column again, and I'm going to sort large to small, identify these places where there are blanks. So here, for this satisfaction, we have some blanks. We have blanks here. And you have to you have to determine where you can actually impute and where you can't impute. So for instance here, there's a 0 here, which makes no sense. There's not even a 0 on the scale. So that's an indication that something wonky occurred here. And I wouldn't even worry about trying to impute this data. There's just no information here that I could use to impute this. However, for this satisfaction, which is important to me, I could use the 4 things that I have and fill in the missing ones possibly. So really quickly, a discussion on imputation. You could do a case-wise imputation or a list-wise imputation. A case-wise imputation is where we try to maintain the character of the data within the respondent. So across the case, we want to maintain the scores that are seem to be going on for a particular respondent on a scale. So for instance here with this respondent, looking at the satisfaction, I would probably impute 4s here because that's what the respondent has scored the other items in the scale. And so to maintain the integrity of this scale, so that the average score for this respondent on this scale will be 4. If I put 4 in all of these, that's what the average score is going to be. Or like down here for this individual, there's 2, 2, 2, or I'm sorry, 2, 2, 3, 2, 2, 2, 2. I would take the average score across the items that have been actually answered in the scale and use that to impute this data point. So if we look at the average score here, I can go down here and look at the average score. It's 2.17. I would actually put 2.17 here. All right. And that maintains the average for this individual on this score. So as this individual scored on his level of satisfaction with this tool, it's going to be a 2.17. And that's exactly what we want to see to maintain the integrity of this individual score. The same thing here. I would put in here in terms of quality, I would put a 3 and a 3 in. Okay, so that's a case-wise imputation. We could also do a list-wise imputation where we, instead of keeping the integrity of the individual, we want to keep the integrity of the score across respondents, right? So this item, we want to maintain the whatever the average is for all the respondents in terms of those individuals that have not responded. So in terms of this individual and this individual, I would take all of the scores on this particular item and average them, and I see that it's a 3.56, and I would impute in here 3.56, 3.56 here, 3.56 here. Okay, so in this case, this doesn't keep the integrity of the score for this individual. However, it doesn't impact the overall score here in terms of this item. All right, so this item and the impact it has on this scale is maintained by putting a 3.6 in here. All right. But is that the truth? I mean, should this be a 3.6, or if I were to actually impute what I thought this individual was, it might change the overall average for this particular item. Again, it's just two ways of looking at how to impute data. Neither one is better than the other one per se. People have debated on which one should be used. I like the idea of keeping the integrity of the individual score because I think that's what we're trying to actually determine, even though I'll say this, we're trying to determine the scale, the overall scale, right? But we're looking at the individual scores and how they determine the overall scale. Some people would argue, since we're looking at the overall scale and that's what we're most concerned about and not the individual, it's better to do a list-wise and keep the integrity of the score based on measures that we have. Again, it's up to you to make that determination. All right. But either way, what I would do is actually do this for all of these missing items. In some cases, I would not try to score them at all, and I would just remove this particular case from any analysis I wanted to use on user. All right. I'm not going to actually fill in these gaps here because it would take me quite a while to do it, but I did want you to understand how this imputation works. So once you began to impute, you want to make sure that you come over here to tracking and describe how you're doing your imputation and exactly how many imputations occurred. You want to be consistent in imputation. So if you do list-wise imputation on one, you want to do list-wise imputation on all. You shouldn't do a case-wise imputation here, but then come up here and do a list-wise imputation. So you want to maintain a standard in terms of how you're doing your imputation. One of the things I mentioned is that in a statistical package, this can happen a lot quicker than doing this in Excel. You kind of have to go here individually and do this in Excel, and it could take a while, but you could do this as a batch process in a statistical package. So that is one of the powerful things about doing this in Excel. I'm sorry, in a statistical package. But there you have it. That's how you would do actual imputation. Okay, so I've gone ahead and just imputed the data, and you could see a lot of the places where data was actually imputed because you don't have a whole number in many of those spots. There are some spots where, you know, if it was all fours, then you're not going to notice. So maybe a 3 was imputed here or 4 was imputed. But you could see all of my blanks are tallying to 0 except for this guy right here who I just didn't have enough information on this scale to do anything with them. So I'm going to leave it as is. All right. So this is what your data imputation would look like at the end of the day. And now you can move forward with beginning your data analysis with doing a factor analysis if you want to do an analysis on the particular scales and how the items are behaving, and your normality test, things like that, and then testing of hypothesis, your descriptive statistics, and anything like that. So there you have it. That's data cleaning for you, the down and dirty of it.
Here comes a brand new flavor in your ear. Time for new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear.